Let's get back to our data. 100 million triplets is huge. And remember that this is only what Netflix released for this competition, but the dataset of all their users and all their movies is actually much, much larger. Let's try to organize this data a bit. The most natural way to do this is to put these numbers into a table where the rows are users and the columns are movies. The cells of this table contain the ratings. The Netflix price dataset had about 500,000 users and 17,000 movies, so we should build a table with 500,000 rows and 17,000 columns. Here is the row corresponding to Frank, and here is the column corresponding to the movie Dirty Dancing. This entry of the table is Frank's rating of Dirty Dancing, a 5. Let's see what our 100 million scores look like in this table. It's a drop in the ocean. We know about 1.2% of the entries of the entire table, and the remaining entries are completely unknown. To be fair, I should say that in the case of the Netflix prize, the goal was to predict only a few missing numbers, about 1 million still. But Netflix needs to predict all numbers every day. This looks like an impossible task, right? How does knowing that Frank is a Dirty Dancing fan can help me predict how Ted is going to like the Western Rio Grande? We will see how our statistical modeling coupled with efficient algorithms can help us extrapolate known ratings to the entire table by leveraging realistic structural assumptions. In mathematics, a table filled with numbers is called a matrix. This is not just to sound fancy. Matrices are a well-studied object in a field called linear algebra. Using this theory, we can not only describe mathematically our structural assumptions, but also leverage a powerful algorithmic toolbox that can be scaled to the size of the whole Netflix dataset and even larger. It turns out that the Tinder dataset is essentially the same. Men are rows, here's Frank, women's are column, and the entries are binary here. 0 if swiped left, 1 if swiped right, and then a lot of question marks. The eHarmony dataset is essentially the same, but the meaning of the entries is not as clear. It's some sort of a compatibility index. It's computing using site information. This is the first thing that a dating site asks you when you subscribe. Answer a long list of questions to collect information about you. They can even extract some of your physical features or type of activities from the photos you post. Exploiting this site of information requires a lot of domain-specific knowledge, and this is a whole field in itself. In a way, this is the secret sauce of eHarmony. Let's go back to our Netflix example. Netflix knows a bit about their users, location, type of credit card they used at the time of subscription, their browsing history, what type of smartphone they use, and a lot about movies. Cast, director, year, rating, budget, etc. Leveraging this information has been instrumental to win the Netflix prize as well. To conclude this video, let me come back to a remark that I made earlier. Netflix may be interested in other objectives than simply recommending you a movie that you will like. For example, Netflix may be interested in showing you as many summary pages as possible to collect even more information about your browsing pattern. To do this, all the numbers fill the table, not just the ratings. Here's another example. Amazon may be interested in recommending a product on which they expect to make more profit rather than the one you are the most likely to purchase. For example, assume that the chances that you purchase coffee machine A are 20% if recommended to you and 10% for coffee machine B. However, Amazon receives $100 each time they sell coffee machine B versus only $10 for coffee machine A. In expectation, Amazon will receive $10 times 20% equals $2 for coffee machine A versus $100 times 10% equals $10 for coffee machine B. So Amazon may be tempted to recommend coffee machine B rather than A. Unlike Amazon or Netflix, who are matching users to products, Tinder or eHarmony are matching users to users. The key difference is that products don't have any preferences, but users do. In other words, Tinder and eHarmony have a more complicated problems on their hands, and we'll touch upon the specifics later in this module. To account for these different objectives, a good data scientist must know what values to enter in the table. Chances of buying or expected revenue, for example. This is again domain-specific, and often several recommendation systems are run in parallel to account for these objectives. To summarize, We've seen that the data can be thought of as a matrix with lots of missing entries. We need to fill out these entries. The meaning of these entries is very much context specific. In the next few videos, we'll see how we can make simplifying assumptions that can help us solve the problem.